All right. Go ahead and write example. Y equals x squared minus 10x plus 21. So we're just going to make sure we understand it. It's like I need to use a thicker, hold on, I'm going to go. Thicker writing utensil so it's all right.
Would you like us to write this down?
I would like you to write this down. Yeah, it's thicker because I'm using a marker. All right, so what do I do first? You subtract the 21. Yep, we're converting the quadratic into vertex form. And the process that we're using is completing the square. So I moved the number over so I have a space so that I can complete the square. What do I do next? By 2. So negative 10 divided by 2 is negative 5. Negative 5 squared is 25. So 25 is the number that completes the square. And if I add 25 to the right side of the equation, I need to add 25 to the left side of the equation.
4.
Okay, so y plus 4 equals something squared.
Y plus 4 equals x squared minus negative 5. Minus 5. Wait, 5. It would be negative 5.
Mm-hmm.
That's what I said. I said negative 5. Oh, girl.
And then you have to move the 4 back over. So then we're going to go ahead and minus 4 and minus 4. So y equals x minus 5 squared minus 4. Okay. What's the vertex? 5, negative 4. What are the transformations? Right 5 down 4. All right. So that's what the graph looks like. What's the end behavior? Well, we would do negative first. So as x goes to the left, y goes up because it's positive. As x goes to the right, y goes up. Okay. All right. Go ahead and flip the page over to the front. So for number 1, what's the very first thing you should do? Ooh.
Oh, that looks scary.
Ooh. All right. We're gonna minus the 7.
That's too far. Oh.
You can just write it on a separate sheet of paper for now. All right, what do we do next? 4 divided by 2 is 2 squared is 4. You did. So we added 4 to the right side. What should we do to the left side? Add 4. So we have y minus 3 equals something squared. X plus 2. And then we add the 3 over. Okay, what else do the instructions tell us to do? It said to put it in vertex form, so we did that. What else does it say? Find the transformations, and what are the transformations? Okay, so we're gonna say left 2, up 3, and then we can move on to the next question. All right, perfect. All right, go ahead and work on that. So we are still converting into vertex form. So we're still doing the same thing. We're still completing the square. That's still our method. The difference is, after you get done with those first 6 problems, is that the a value does not equal 1. So if you look at the first 6 problems, they all start off with just plain x squared. The rest of the problems have a number in the front or a negative in the front or something that makes it so it's not just a plain x squared. So that's what we want to look at, is how to do problems like that. So for our first example problem, we're going to do y equals 2x squared minus 16x plus 33. And we start these off the exact same way that we started the other ones off. So what is the very first step? Minus 33. So starting it off exactly the same way. So we have y minus 33 equals
2x squared minus 6.
Okay. Now, the difference here is that we can't have the number in front of the x squared. So what we do is we factor that number out. So I'm going to write 2, and then I'm going to have a big set of parentheses. X squared. What happens when I divide 2 out of the 16? I get 8. So minus 8x plus something. Okay, so what do I do now? So negative 8 divided by 2 is negative 4. Negative 4 squared is 16. So the number that completes the square, we're finding the exact same way. Still divide by 2, still square it. Now on the right side, it looks like we added 16, but we didn't really add 16. We really added 2 being distributed to 16. So what happens when you distribute the 2 to the 16? Yeah, you multiply, and what do you get? 32. So we didn't add 16, we added 32. So if you add 32 to the right side, what do you have to add to the left side? 32. So it's almost exactly the same. There's just a little bit extra with a number in front of the parenthesis. Just a little bit more. So now we have y minus 1 equals 2, and then we have our parentheses squared. And what goes in our parentheses? X minus 4. You still add the 1 to move it over to the other side. Yep. So we would say, yeah. So right here, see how it says plus 16? But there's a 2 in the front, and if I multiply 2 times 16 is 32. So I didn't just add 16, I actually added 2 times 16, and that's why we did the 32. So when we move the 1 over, that gives us y equals 2 times x minus 4 squared plus 1. And then what are the transformations? Vertical stretch of 2, right 4, up 1. Good. Good, yeah. Okay, can we do another one? We're good. That was it. That was it. Everybody's totally fine.
Yes.
They're not all totally fine.
Yes.
You got some people who looked like a puppy just got hit by a semi truck. So we're gonna do another one.
Oh my word.
See, I love that.
I'm so happy about the little dog butt. Look
at the
at
little
puppy.
Cat butts. Yeah. They're all cats.
I told you I'm scared of that.
All right. All right. What is my first step?
-5.
Plus 5. But is it the same thing? All right. What's wrong with the x squared this time? There's a negative. So what do we need to take out this time? A -1. So we have x squared. What happens when you do 6 divided by a -1? -6.
I'm doing great.
So we had a negative in the front, so we're taking out the negative in the front. And then what do I do next? Divide by 2. So -6 divided by 2 is -3. Okay, don't say anything out loud. Don't say anything out loud. Don't say it out loud. We didn't really add 9. Don't say it. We really did something else. And then do it to the other side. Don't say it. Don't say it. Just do it to the other side. So we didn't really add 9. What did we actually do? We subtracted 9. So if we subtracted 9 on the right side, what do we have to do to the left side? Subtract 9. So we have y minus 4 equals a negative in front of something squared. Is it okay that I switch that from a -1 to just a negative? Yeah. Are you guys okay with that? And in the parentheses we have x minus 3 and then we add the 4. All right, we have to do at least one more example because we have to see one that has a fraction. I'm positive. I mean, unless you want to do the fraction one yourself without help. Yeah, I mean, I'll put it up and then we'll see how far we can get with it. Okay. All right. Does everyone have that example written down? Yes. Okay. No, we gotta do a fraction one. All right. Y equals 1/2 x squared minus 4x plus 12. It works the same. It works the same, yeah. Okay, so go ahead and do the first step. Don't say anything out loud, just do the first step. And you gotta write it down. Because this is a good cheat sheet problem eventually. If all your notes are on exactly one page, yes. If not, no. Yeah. So the first thing we did was what? Minus the 12. So we have y minus 12 equals 1/2 x squared minus 4x. And then what's the next thing that we do? Take out the 1/2. And 4 divided by 1/2 is not 2. 4 divided by 1/2 is not 2. 4 divided by 2 is 2. 4 divided by 1/2 is not 2. 4 divided by 1/2 is, I heard it, it's 8. So if you do, Yeah. So if you do 4 divided by 1/2, you're basically saying how many 1/2 cups show up in 4 cups? 8 of them. When you take a number and you divide it by a fraction, the number gets bigger, not smaller. So 4 divided by 1/2 is saying I've got 4 whole cups. How many half cups show in those 4 whole cups? It's 8. So this is actually x squared minus 8x, and that is the part most students will get wrong when they do this. So the fraction works the same as everything else. You just have to remember that when you do 4 divided by 1/2, you get a bigger number, not a smaller number. All right, what do you do next? So -8 divided by 2 is -4. Okay. So 16 is the number that completes the square, but we didn't really add 16. We really added half of 16 because this time we're multiplying. So what is half of 16? That'd be 8. So we didn't add 16, we added half of 16, which means we added 8. So if we add 8 to the right side, what do we do to the left side? Add 8. Okay. Y minus 4 equals 1/2 times parentheses squared, x minus 4, and then so we have y equals 1/2 x minus 4 squared plus 4, and what is the vertex?
4.
4, 4. What's the transformations? Right 4, up 4, and vertical compression of 1/2.
I said that, and you shook your head no.
I heard somebody say stretch. What's the end behavior? As x goes to negative infinity, y goes to positive infinity. As yep. Is the graph continuous? Yes. Are these ever going to not be continuous? No, they're always going to be continuous. What's the range? The range. What's the y coordinate right here? 4. So 4 positive infinity. 4 comma infinity. Where do we have parentheses brackets if we have 4 to infinity? Parentheses on the infinity, bracket on the 4. Okay. All right, so go ahead and go back to the assignment. All right, number 6.
Are we doing this together too? The second number.
You go, yeah, the second number 6, not the first. Okay, go ahead and write down the first step. Do the first thing. The second number 6. Do the first step. Go ahead and do the next step after that. So we got to take that 2 out. Go ahead and get the next step. What number should I be adding to the other side? 8. Why am I adding 8 to the other side? Yeah, because it looks like we added 4, but we really did 2 times 4. What part? So we had added the 3 over, right? And that left us with 2x squared minus 8x on this side. And so we put the 2 in the front, and when we divided by 2, we got x squared, and when we divided by 2, we got negative 4x. And then we did negative 4 divided by 2 is negative 2. This is our... So what you'll notice is the more you do this, the more you want to start like skipping steps so you don't have to write down as much. And until you have done these problems for a long, long time, skipping steps will make you forget things. All right. So a lot of students will not do the part where they divide by 2 and square it, and they'll miss that part where you have to add something to the left side. Adding something to the left side is probably the most common step that gets skipped. So make sure that for today you show all of your work on these, not because Ms. Rice told you so, but because a lot of students will get it wrong if they start to skip a step too early. Okay. So we've got negative 2. Negative 2 squared is 4, so 4 is the number that completes the square. But we didn't really add 4, we actually added 2 times 4, which is 8. So I've got, since I added 8, I've got y plus 11 equals 2 times, and then what should be in my parentheses? X minus 2, and I got that because negative 2 is the number that I got when I divided it in half. So whatever I get when I divide by 2, that's the number that goes in the parentheses. And then what do I do to finish up the problem? I take the 11, I minus it over. So I have y equals 2 times x minus 2 squared minus 11. And what are my transformations? Perfect. All right, do we want to walk through another one together like that? No? We're good? We're good? Okay, so go ahead and work on that. Answers are on the board. When you get to the last page, it's gonna start to ask you questions. We did one assignment like this before, so I will come around and talk to you guys individually unless you guys are all asking questions at once, and then I'll do it in front of the class, okay? But when you get to number 14, feel free to call me over and we can talk about it, okay? All right. All right, so it says, where is the function negative? Anyone remember what I mean when I say the function? The line, yes. What else do I mean? The equation. And so this is the function is this stuff. What letter goes right here? If I didn't use f of x, what could have gone there? Y. So over here, when I say where is the function negative, I'm really saying where is y negative? Where do negative y values show up? Tell me on the graph, where do negative y values show up? Say it again. Negative y values. Where do negative y values show up in general on any graph? Yeah, in the bottom, right? This is where all the negative y values are. So if we're asking where are the negative y values for this picture, they're going to be right here. They're going to be all this stuff that's underneath the x-axis. So when they ask you the question, where is the function negative, they're really saying, look below the x-axis. That's what they're actually saying, is what part of the graph is below the x-axis. Okay? When they ask for the zeros of the function, anyone remember what another word for zero is? X-intercept. What is the x-intercept of the function? That's what they're asking for. Here, they're saying, where is, instead of f of x, I'm going to put a y. Where is y greater than 0? Where is y going to be greater than 0? Or where is y positive? The top part, right? This is where all the y coordinates happen to be positive. So when they say where is the y value positive or where is it greater than 0, we're talking about above the x-axis. Okay, so what we need to figure out is we need to know what these x values are right here and right here, those x-intercepts, because in between those x values, the function is below the x-axis. If we look to the left of the x-intercept and to the right of the x-intercept, that's where the function is above the x-axis, okay? So on your calculator, we're going to go ahead and graph this. So we have 2 times x minus 3 squared minus 1. And I'm going to hit the graph button. We're all graphing it. And then what do I do to find the intercepts? Second trace number 2, I'm looking for the zeros of the graph. Now it says left bound x is at 0 and I can't see it. I know that my x-intercepts are over here, so I'm going to hold the right arrow down because my x-intercepts are to the right of 0. So left bound, your cursor can be anywhere to the left, but that's a good spot if I'm to the left of the point. So I'm going to press enter, and then for right bound, just go a little bit more than the x-intercept. Press enter. The guess is always silly. So my x-intercept is 2.293. So here, what are the x-intercepts of the function? 2.293. That's one of the zeros of the function. That's what they call it. And then I have to find the other one. So I'm going to do second trace, number 2. So this time when I'm looking for this x-intercept right here, the left side of it is going to be underneath. So I'm on the left side of it right now. So I'm going to press enter. And then when it asks me for right bound, I'm going to hit the right arrow and press enter. So my right bound is 3.7, or sorry, my 0 is 3.707. So if I look at x values between 2.293 and 3.707, all of those x values are going to give me negative y coordinates, and I'll prove it to you. If I do second trace number 1, go ahead and do that second trace number 1. And then if I pick a number that's in between 2.293 and 3.707, like the number 3, it gives me a negative y value. If I do 3.1, it gives me a negative y value. 3.2 gives me a negative y value. 3.3 gives me a negative y value. 3.7 still gives me a negative y value, but if I plug in 3.8, it's going to give me a positive y value now because I'm no longer in between those two x values. You guys see that? So what I'm going to write is, where is the function negative? It is negative between 2.293 and 3.707. That's where it's negative. It is negative between those two numbers. Why did I not put a bracket? Yeah, the reason it's not a bracket is because if I was to plug in this number exactly, it would give me a y coordinate of 0, and 0 is not considered to be a negative number. So I don't put a bracket because I'm not going to include that. Plugging that number in should not give me a negative number. It should give me 0. All right. If I look down here, I want to say, where is the y value going to be positive? Then I can choose numbers to the left of 2.293. So if I choose like 2.2, that's to the left of that decimal, that's a positive. If I plug in 2, I get a positive. If I plug in 1, I get a positive. If I plug in 0, if I plug in -5. So any number to the left of this is going to give me a positive y coordinate. So how do I write that? That any number to the left of this is going to give me a positive y. Negative infinity to 2.293. Now this says greater than or equal to 0. What happens if I plug in 2.293? I get 0 exactly. So I'm going to put a bracket there because it's going to equal 0 exactly. And that's okay. All right. Now we have to have another set of answers because we have to have this part over here. So if I plug in 3.8, I'm going to get a positive. If I plug in 3.9, I get a positive. If I plug in 5, if I plug in 9, if I plug in 10, all of those are positives. So what else should I put for my answer? Okay. And then what should I put around these? All right, and then anytime you have two answers like this, you put a U in between them, and the U means union. It means both of those have to be included. If you don't include one of them, then you're wrong. So it means this answer and this answer at the same time. You have to have all of them. Where is the function increasing? It's not a crazy question. I know these other ones have been weird, but this one is going back to normal. Where is the function increasing? Our normal increasing, decreasing. So we have a little stick figure guy. What's he doing first? He's decreasing until he gets to an x value of 3. And then he starts increasing. It would be 3 comma infinity. And why did I put a parenthesis? Because it's just a point. It's just a point at 3, and there's no slant up or slant down. That's just a single point. All right, go ahead and flip the page. All right, so what do I mean when I say, where is the function positive? What do I mean when I say, where is the function? What do I mean by the function, the y? What do I mean when I say, where is the y positive? Where do I want you to look? Above the x-axis, so here, this stuff right in here, above the x-axis, that's where you're going to look. What do I mean when I say, what are the zeros of the function? I mean the x-intercepts. So this part right here is going to be your answer for number 18, the part that's above the x-axis. What do I mean when I say, where is f of x less than 0? So f of x is y. What do I mean when I say, where is y less than 0? I mean to look below the x-axis. So these questions are almost identical to the problem on the previous page. Almost identical, just a different situation. But they're asking you the same types of questions. Okay. These questions, this is practice. These questions will not show up on this unit test. They will show up on the next unit test because I want you to get comfortable with them before I test you on them. But that means that you need to start asking questions on this now if they don't make sense, okay? Because they will start being on tests soon. So tonight's homework is to finish the packet. All right. If you do not have a graphing calculator at home, then you should download an app or use Desmos.com. Desmos.com is very cell phone friendly. Okay, Desmos.com, you can use that as well. So you need to finish the packet. That's your homework tonight.